Hola, Team Bio. I'm on SAC duty right now. This is very exciting. Hanging out in SAC, watching freshman boys play video games. If you want to come on down Saturday between 12 and 3, I'll be here. It's very exciting. Okay, so, but getting to the point. Today's screencast is the connection between cell respiration and ventilation. Well, actually, it's not really. We're going to talk about the heart and how it pumps blood around the body, but you need to understand the connection between cell respiration and ventilation. Cell respiration being the biological process we've been talking about the breakdown of glucose, and the slow oxidation of glucose into CO2. And ventilation is basically getting gases to be exchanged. So obviously CO2 is being produced. Sorry, someone just came in and asked me a question about renting sleds, and I totally forget where I was. I think I was talking about gas exchange. So CO2 is being produced. So CO2 needs to get out, and O2 needs to get in. And I think you all know that what carries CO2 and O2 is blood. Hemoglobin in the blood is binding CO2 and or binding O2, and then also partially binding CO2, and a lot of our CO2 is dissolved in the blood and creates carbonic acid. So the blood is carrying these dissolved gases, but we also need something to circulate the blood, and what circulates it is the heart, and also the cardiovascular system. So the cardiovascular system is the heart, cardio, and the vascular system is all our arteries and capillaries and veins. And so this screencast is going to be dedicated to talking about the heart and how it pumps blood around the body. So if you go onto Google Drive, in our activities folder, there's a heart diagram that I would like you all to download and import here. You can also just Google heart diagram unlabeled and probably find it on the web. But make sure you have the same diagram I have. It'll be easier to label. So I'm going to import it in here. So here's the diagram of the heart we're going to be using, and make sure you have one that looks like this or very similar. Okay, so the first place we're going to start out is we're going to label the sides of the heart. This side is the right, and this side is the left. And I know looking at your screen, you're like, wait, hold on, but that's backwards. But imagine picking up your iPad and sticking the back of it with the Apple sign on your chest, such that the heart is facing outwards. And you'll notice that now the right and left match up with how I've drawn them here on the screen. So it's important to notice that you're looking at right now someone else's heart, and so but we talk about the right and left side of the heart from the perspective of being in the body. Okay, so we have the right side and the left side, and the first thing I want you to label is this bit up here. It's called the aorta. Okay, so here you go, the aorta's up here, and the next thing I want you to label is this valve up here. This is the superior vena cava. And the superior vena cava is, so the aorta, let's first talk about for a second about arteries and veins. Arteries are always going to be leading away from the heart, and veins are going to be leading back towards the heart. And the superior vena cava is a vein, and this down here is the inferior, vena cava. And these both dump in to this area right in here. They're both, it's kind of hard to see, it's easy to see the connection here, but a little bit more difficult to see the connection here. But they both dump into this space right here, which is called the right atrium. Oops. And then the right atrium is connected to this, which is called the right ventricle. But in between them is kind of a series of like a little door. And this is called, it's a valve, it's called the tricuspid valve. and it's called the tricuspid valve. It's got kind of like 3 different sections or segments to it that all come together and close. Okay, and then from the right ventricle, we're going to go up here to this section right here. This is called the pulmonary artery. And it's pretty easy to see, but it splits off into 2 sections. So one side of the pulmonary artery goes this way, and the other goes underneath the aorta and back out this way. Okay, and it's called pulmonary artery because, again, it's leading away from the heart. It's taking blood away. And it's the pulmonary artery because it's delivering blood to the lungs. Okay, next is definitely probably the hardest piece to see. But there are 4 pulmonary veins that are bringing blood back from the lungs back to the heart, and they are here. 1, 2, 3, 4. So I'm going to label them now. Okay, and then these pulmonary veins dump back into this section, this chamber of the heart right here, which is, again, a little hard to see how these connect, but they connect back into this section, which is called the left atrium. And the left atrium is connected to the right ventricle, so that's wrong, the left ventricle. By, again, a valve, but this one is called the bicuspid valve. Okay, so, and then back from there, from the left ventricle, we connect again up to the aorta. Okay, so now you have all the different veins and arteries and chambers of the heart labeled. I'm going to start drawing in the direction of blood flow here. And I'm going to use blue for deoxygenated blood. So this blue will be deoxygenated. And I'm going to use red for oxygenated blood. And I'm probably going to change my pencil thickness. Okay, so we start coming from both the superior and inferior vena cava. They are bringing deoxygenated blood from the rest of the body. They collect all the blood that's coming from the body, and they dump it into this right atrium here. And from the right atrium, the blood is going to flow into the right ventricle, and then out of the right ventricle, out of the pulmonary arteries, out to the lungs. There in the lungs, gas exchange happens, and CO2 leaves the blood, and O2 enters the blood and binds to hemoglobin. So by the time you get to the pulmonary veins going back into the heart, the blood is red and oxygenated. And then again, these all dump into the left atrium, and I'm just going to draw the connection between this one up here because it's easy to see. And again, maybe I should draw this connection right here. It's blue. Okay. But they all jump into the left atrium, and from the left atrium, they enter the left ventricle, and from the left ventricle, they go out the aorta, and they're going to be pumped there to the rest of the body. And they continue actually on down here. And it's not drawn in here, but you can actually draw on the bottom of your heart a little section right here. And this is part of the aorta, and you'll actually have blood descending here out to, for example, your legs and your lower section of your body. Okay, so this is how blood flows through the heart. And the first thing I want to talk to you guys about the heart pumping the blood is actually, it would be, people kind of think, okay, so probably this this part of the heart squeezes, and then this part of the heart squeezes, and then this part of the heart squeezes, and this part of the heart squeezes. But that's actually not how the heart works. There's coordinated contraction. So the right and left atrium actually squeeze at the same time blood into the right and left ventricle, and then these two ventricles squeeze blood at the same time out either to the lungs or out to the rest of the body. And now, if you zoom in here, this might be a little hard to see, but if you look at the wall thickness of the left and versus right side of the heart, you'll notice that the left side of the heart is much thicker than the right side of the heart. This is not a fantastic diagram, but down here you see the thickness is more. Okay, so the left, we might even exaggerate it a little more. You'd have a pretty thick heart over here. And this is because the right ventricle only has to pump blood to the lungs, which are really close by. If you think about the location of your heart in your body, it's right next to your lungs. So this blood doesn't have to be pumped that hard to get to where it's going. However, the left ventricle has to pump blood out through the aorta around and circulate around the whole body, get to the very tips of your toes and all the way up to the top of your head. So this side of the heart is actually much thicker. And then, so that's the first thing I want you guys to notice about the structure of the heart. And then the second thing I want you to notice is that there's no mixing of oxygenated and deoxygenated blood within the heart. There's a separate system for deoxygenated blood and for the oxygenated blood. So we have no cross-mixing of blood within the heart itself. And the last kind of interesting thing to think about is if you put your head on someone's chest and you listen to their heartbeat, that lub-dub, 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 lub-dub sound, well, that's actually the sound of the valves, the tricuspid and bicuspid valve closing, snapping shut is the lub part, and then the dub part is the, now I forget the name of these valves. The valves, let me look that up. Okay, this is just called the pulmonary valve right here, and this is called the aortic valve. But the lub part is these two valves snapping shut at the same time, and the dub part is these two valves snapping shut at the same time. So when you're listening to someone's heartbeat, it's not really the contraction of the heart that you're listening to, but instead the closing of the valves, which is kind of interesting. Okay, so this is it for the screencast. This is going to be useful to you because we're going to be talking more in the coming week about stresses on the human body and what happens when we climb to very high elevations where the partial pressure of oxygen in the air is very low. Okay, so that's it for today. Hope you enjoyed. Bye.